These are the lesson 5.1 notes on ratios. This is the first lesson in a new unit on ratios and percents. The key idea from this lesson is that a ratio is a comparison of two quantities. Ratios can be part to part, or they can compare a part to a whole, or they can do the reverse of that and compare a whole to a part. If you have a part to whole relationship, a part to whole, that's called a fraction. So ratios lots of times look like fractions, and they are related to fractions, but they're a little bit different, because when you are talking about a ratio, it doesn't always have to be a part to a whole. It could also be comparing a part to a part to a part. So we have some examples using these crayons. If you are looking at it online, you'll be able to see the colors. And if you are looking at a hard copy that I printed, you won't be able to see the colors. So I'm going to color in, and then we will write down how many of each one we have. This one is red, and this one is red, and all the rest of them are blue. I don't have a color printer in the room. So there we go. And we'll just write over to the side. So we have 2 red, and 1, 2, 3, 4, 5, 6 blue crayons. And then let's practice writing some ratios. You can write them. See, some ratios are 2 red crayons to 6 blue crayons. So we have 2 reds to 6 blue. That's a part to a part. Or you could simplify that and say I have 1 red crayon for every 3 blues, because here's 1 red that goes with those 3 blues. I could flip that around and say I have 3 blues to 1 red, 3 blues to 1 red. I could say, 3 blue crayons out of every 4 crayons. So sometimes we use the word 2, and sometimes we use the word 4. Sometimes we use the word per. We use that a lot with fractions. Also, out of. So 3 crayons out of every 4. That sounds like fraction language too, right? Because this would be a whole. And then algebraically, we can write that as the ratio of A to B can be written as A dot dot B. Okay, so we can write ratios 3 ways. We can use the word to, or sometimes we use a dot dot, and sometimes we use it so that it looks like a fraction. Okay. All right, so now we're going to do a little bit of practice, and we have some coins here. And again, it can be hard to tell what's what. So let's just do a little count. We have some pennies. There might be some nickels in there, and some dimes, and some quarters. And we'll just count them up. All right, let's see, I see quarters. I see 1, 2, 3, 4, 5, 6. Did I miss one? 1, 2, 3. Oh, 7. 1, 2, 3, 4, 5, 6, 7 quarters. If we count the pennies, there's 1, 2, 3, 4, 5, 6 pennies. There are 0 nickels. And there are, that's a dime, and that's a dime. So there are 3 dimes. All right, so there'll be a little cheat sheet over to this side. All right, so some different things that you could write down. We could compare the number of pennies to quarters. pennies to quarters. So we could write that two different ways. We could write the 6 pennies to 7 quarters. So you could write that 6 to 7. Or you could write it 6 dot dot 7, 6 to 7. And those are both ways of showing ratios, right? Because this is a part to whole, we're not going to write that as a fraction right now, right? Let's look at quarters to dimes. How many quarters are there? I see 7 quarters. 7 quarters to 3 dimes. Or I can do it as 7 to 3, like that. Or we could do a part to whole, where we have like dimes to the, T-O-T-A-L. And let's add that up and see how many total points we have. We've got 6, 7, 8, 9. 9 and 7 is 16 altogether. So my dimes to total would be either 3 to 16, or I can write out the word 3 to 16. I could write it 3 out of 16. And because this is a part to whole, it's appropriate to write it as a fraction as well. Okay. And then I think you try might have gotten, yep, you try went over to the next page. Right. So you're just going to write the ratio of dimes to pennies. Right. In example, right, in this example, I'm going to actually walk you through this one a little bit, and you try to. I've got a circle graph that shows the favorite toppings of several students, and that line can be hard to see. There's a little line there, right? So some students liked bananas, 9 students liked bananas, 4 students liked strawberries, 1 student likes coconut, and 5 students like peanuts, right? So we've got several students. You're going to use ratio language. That means you're going to use the to or the dot dot to compare the number of students who favor peanuts to the total number of students. Okay. All right. And then we get to my favorite thing. We're going to do a tape diagram. A tape diagram is such a useful and powerful visual. It's a way of representing the information that makes it really clear and easy to understand ratios, which can be really kind of tricky to visualize in your head. So to use a tape diagram, it says the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. So you make more than your friend, the ratio of yours to your friend, right? And as you're reading through, the order matters. So it says your monthly allowance to friend's monthly allowance. So there's the 2 is the dot dot. And the order matters. So this is you, because you were first here, and this is the friend, right? And the monthly allowances total $40. How much is each allowance? Now, trying to figure that out in your head can be a little confusing, but if you use a picture to represent it, it becomes much clearer. So we're going to make one kind of tape that has 5 pieces in it. This is for you. I'm going to draw 1, 2, 3, 4 lines. Try to make them about the same size, right? And then your friend. So 5 parts for you to 3 parts for your friend. I'm going to make them as even as I can. So we can see that those are the same size parts. Okay, so I have a total of 8 parts. So it's like I took all of that allowance and I divided it up into 8 parts, 5 parts for me, 5 parts for friend, right? Then the total of those allowances is $40. So I can take the $40 and I can divide it by the 8 parts. And that tells me that each part is worth $5 per part. And so let's go back and put 5 on all of these. This part's worth 5. And then it becomes very clear that your part is 5, 10, 15, 20, 25. And friend is 5, 10, 15. And 25 plus 15 equals the $40 total. Isn't that nice? Lots of times kids will try to take this total and they'll try to divide it by 5 and they'll get 8 and then that's confusing, or they'll take the 40 and try to divide it by 3 and that's confusing. Making that tape diagram really helps you to see what's going on and to get your thinking organized. In the you try, there it is. Okay, very similar. You now have the ratio is 2 to 3. So again, this is you and this is your friend. Maybe your friend got a raise because now they're making more of the money. All right, but it's still $40. Right, so draw your tape diagram. All right, now we're going to use it in a real life problem. And this problem's got several steps, but it's a nice problem because it's about garlic, which is one of my favorite things. All right, so here we have garlic. If you cook with garlic at your house, you know that it grows. It's like an onion. It's got a little root down here that grows, and then this comes up, and it's the green part. And in the spring, it's a little tiny thing of garlic that looks almost like a green onion or a scallion. And then as the season goes on, it gets papery on the outside, and each of the little parts inside divides up and makes cloves. So these are papery, and you take the little papery wrapping off like onion, and then you chop it up and cook with it, right? And you can also plant these individual little cloves, and then they will grow into a whole new bulb of garlic the next year. So each little clove of garlic grows into a big bulb, right? So this problem says that you are taking 42 bulbs of garlic. So you've got 42 of these big guys, and you're dividing them into 2 groups. Some of them you are going to plant, and some of them you are going to cook, right? You are going to plant 3 bulbs for every 4 bulbs that you use for cooking, right? So there's the dot dot, 3 to 4. Every bulb has about 8 cloves. About how many cloves will you plant? So we're going to save that last sentence for the end of the problem. All right, so let's just start by making that's a lot of information, right? That's really a lot going on. It's kind of confusing. Look how clear it is once you do the tape diagram. All right, so I know that I'm going to have 3 bulbs to 4 bulbs. So I will start by making a diagram that has 3. I'm going to need to divide this up. This is for planting. And then I'm going to cook with some of the others. And I see that there are 4. I'm trying to make them about the same size. 1, 2, 3, a little bit more. Okay. All right. So now I have 1, 2, 3, 4, 5, 6, 7 parts. all together. All right, so I'm going to take my 42 bulbs of garlic and I'm going to divide it up into 7 parts. So 42 bulbs divided by 7 parts. I should have written that as a fraction so we could see that that is 6 bulbs per part. All right, I'll write it like that. Bulbs per part. Divided by per. So I'm going to take 6 and I'm going to put 6 bulbs in each of these parts. And now it's very easy to see that I'm going to plant 3 times 6 equals 18 bulbs. And I'm going to cook with 4 times 6, which is 24 bulbs. All right? So you would probably store them like that. And then when it comes time for your spring planting, then you would take those 18 bulbs and you would break them apart into the individual little cloves, and then you would plant the cloves down in the ground. You put them, this little rooty end down first, and then they come up like magic. All right, so let's see. Let's decide. We'll take the, see, what does it say? How many cloves will you plant? So we're going to take 18 bulbs times, it says there are 8 cloves, so there are 8 cloves per bulb. I have bulbs in the denominator here, and I have bulbs in the numerator here, so that kind of cancels out. It is a good thing to know that you can cancel units as well as canceling numbers. And now I can use my calculator and I can multiply 18 times 8, and that is 144 cloves. That's what's left. Wow, I'm going to plant 144 cloves of garlic. And then next year, instead of having 42 bulbs of garlic, hopefully I'll have 144. And I'll have enough to use and maybe even to share with my friends. All right, now it's your turn. What if, in example 3, you just planted 1 bulb for every 2 bulbs that you used for cooking? Would you plant more or fewer cloves than originally planned? And you need to explain your answer. So yes or a no is not acceptable. You need to actually do the work.